Okay, so thank you very much for joining me in this presentation. I am Alessandro Calzavara, and today I'm going to talk about the state of declarative UI, specifically for mobile development. And obviously, it doesn't update the other side. Yeah. One sec. So let's do it this way. That's better. Right? Great. Sorry. So my name is Alessandro Calzavara. I'm mobile tech lead at Spreaker. Spreaker is a podcasting platform that allows users to create content but also monetize from their effort. I'm also a meetup organizer for the market user group, which we organize one talk a month around Treviso. Try to bring new stuff, but also a regular tech discussion. I'm also a barbecue fan, but for today, we're not talking about meat, we're not talking about programming. So sorry, in case for another talk. For today, we're going to briefly talk about imperative UI, or say the imperative approach to building UI element, the rise of declarative UI, and then the challenges that this brings to the table. Finally, some wrap up, obviously, just to say, which is very, very good. Let's start from imperative UI. Imperative UI is simply put, using the imperative approach to building UI. That's pretty much the pattern that we use for writing most of the code, and it's pretty much a sequence of instructions that allow the compiler or the application operating system or the framework to actually build the UI, and specifically to bring the UI in the state that you want to be. It's expressed in a way that how the UI should be look like because of all the changes that you are applying to it constantly. This is an example on Android using regular layout. As you can clearly see, the instructions are very, very simple. You just need to pick elements from the UI, from the basic layout, and then you apply a set of properties on top of that. You can set the title, you can set the text in the sense, but also the visibility. So you can also decide which element that you are prepared to be on the UI can actually be hidden or not seen anymore, or any kind of that. So plenty of property. And this is pretty much what you can expect from imperative UI. Which is very simple to understand because all the instructions are imperative, so there's nothing hidden inside. You can see exactly what the UI needs to do in order to render in the exact same point in which you want the UI to be, but also very verbose because again, you need to write a lot of code. That's another way of saying it. And you have to also keep the UI state in sync constantly. So what is something changing in your app state? You need to do a set of commands to make the UI in sync with that. So you are setting the text maybe, sure, but maybe also set the color based on other properties. And you need to invoke that part of the code every time the app state changes. This is up to us as developer when we're using imperative to actually execute that part over and over again. Whenever something changes, we need to take care of that. It doesn't come for free. So everything is manual in this sense. It would be awesome to have a different way of building UI, which we do have now. So let's go towards the direction and how the declarative UI start coming as a very, let's say, competitive alternative to imperative UI development. The first one comes from React from 2013 on the web, as many of the major, let's say, probably approaches to development come from the web because probably we have more web developer than mobile developer, which makes sense. So in 2013, Facebook presented this framework for building UI, which brings this statement as the UI is a function of the state. So it's always, the UI is always driven by some changes on the state. It represents pretty much what the UI should look like based on the state in that specific moment. It doesn't ever talk about how to update the UI. This is completely out of the question. But this is just to say, you set the state and the UI will simply follow. It will just be a representation of that. It's based, on my opinion, on 3 blocks. The first one is that you are enforced to explicitly set the property on the state that you need for the UI. There's nothing hidden inside. So if something needs to be put on the UI, you need to have it in the state. Otherwise, it doesn't work. And that gives you for free the fact that whenever the state changes or any property of the state changes, the UI will change automatically. This is, of course, the cool stuff, right? So you don't need to write about or handling changes in the UI. That's come for free because we're defining everything you need into the state. And the third element is that it actually pushes you to create views which are from the smallest one to the biggest one and compose them into a complex one layer at a time. That gives you also the option of actually the method to increase the reuse of views. So you are building something on a form, for example. You can create your own custom form. It's just a view in Compose or any other technology, actually. Then use that in many different places just by driving the state for that specific form. So you are able to use the same exact form, structure, and behavior only on other places in the application. So again, very good, the fact that you write, generally speaking, less code than before. It gives you, again, UI updates for free. So this is, of course, part of the place. But it requires you to change the way you think about building UI. There is a sort of mental shift that you need to do in order to use this tool properly. If you try to use imperative approach into declarative UI, it doesn't work. Or if it works, it works pretty much not the way it's supposed to work. So let's try to be very pragmatic on this. You need to change the way you build UI. It's kind of the final point, probably something on the past. The fact that declarative UI handle the changes by itself means that there will be an algorithm that tries to understand whenever the state changes and what of the UI need to change to try to minimize the work that needs to be done. And back in the days, it was kind of expensive. It's not a problem anymore, so it's very like, not a big deal any days. Because the devices actually improved a lot. And so in any case, and also the code probably has improved a lot. So there's been done some great work there to try to minimize the work. And also, fun fact, in some cases, it's much simpler to simply redraw the whole UI just in one single step instead of just changes little details here and there. But it is led to the system and also to the framework to decide whenever this makes sense or not. So React was the first one in 2013, 10 years ago. Not a new technology, I want to say. And from this, something derived, which was based upon React, but it was targeting native, so React Native, name implied. It's built on top of React in my experience, so you still have to write JavaScript code, but the engine inside doesn't render HTML and CSS. It renders actually using platform-specific API and UI elements. So it's not a web view embedded, it's not that kind of product. So it's built to be used as a cross-platform tools. The fact that it's on the engine to decide which is the element of the platform to be used. You see that you can create the code and use the same code that running on both platforms and having some native UI on place. It gives you something that was never a thing on mobile development, which is the hot swap code or the hot reload, that's how you want to call it. The point is that you're just writing the code on your IDE, you're saving the file, and that gets automatically and immediately be rendered and re-updated on the device or on the simulator right away. That gives you a boost in terms of development because you don't need to recompile, wait, installing the application. And moving forward, you can just go straight there and everything works much, much faster. Performance-wise, it's not as performant as native code, but again, nowadays, performance are much more improved. And so in most of the cases, it's not a problem that we should deal as a developer. For many applications, this is totally fine. The user will never experience any big issue. And so it's totally a valid option when building a native UI. Customization, yes or no. The fact it's built on an abstraction on top of the actual native API means that at some point you're going to lose some detail, some specific things that you might have when building UI with native components or native platform, native frameworks. But again, as we said before, it might not be a big issue anyway. It's mostly depend on the design that you want to apply to. So it's there, it's a limitation, mostly for updating in terms of new API be presented. They need to be integrated inside to other users. There is a microphone issue again, I guess. I don't know. Well, you can hear me, at least. Okay, it disappears. So very good. Auto reload in this case. So again, you might need to wait maybe a few months to actually be able to use new APIs, but it's not a big deal. Again, for most of the cases, it's not a problem. So React Native was 2015, it's been presented, still 8 years ago, not a lot. And the next one on this list is actually something completely different, which is Flutter. Flutter was presented in 2017. It is declarative as approach as much as React Native. It is multi-platform by default, and by multi-platform also includes web development. But it's a bit different in the sense that it doesn't render or doesn't use UI API to render element. It's actually draw all the pixel on screen like it was on a canvas. So it's on the engine to actually drive or design whatever they want. And it's about Flutter to do that. This also gives you some nice or fun experiment to play with. So using the iOS look and feel into Android and vice versa. It is totally doable. Not really makes sense, but it is doable. But again, this is because it is the framework to actually drive and design, or drawing all the pixels on the screen constantly. And then we are probably to the part in which you are probably more familiar with, or in any case more interested about, which is SwiftUI and Jetpack Compose. Started in 2019, they were unusable back then. It became a long way from that, but those are actually the ones that we're gonna probably more focus on from now on into native UI development. SwiftUI again is declarative, is based on Swift, and it's a language that actually grow a lot. Also in the backend, as been said also in a few talks this morning, but it is a language which is super modern, like Kotlin, and it gets a lot of attention and usage for features that has been actually part of the SwiftUI implementation. Without Swift, you wouldn't have SwiftUI in any case. Sadly, because it's an Apple thing, it actually takes a very slow time to improve because you need to wait for the most part 1 year to see bug fix or any case improvement to the design and the code. Because specifically for SwiftUI, this is implemented for many components into the OS directly. So you need to update the phone to the latest version of the OS to get also the benefit of the latest version of SwiftUI. This is the way they implemented this, and it's not the case for Jetpack Compose. Jetpack Compose, on the other hand, is still declarative, obviously, but it has a wide range of support. It goes back to Android 5, which is Lollipop. I don't know how many of you have an Android phone with Android Lollipop back in the days. Probably nobody, and you shouldn't do having that now, in any case, but it is super supported. And it is released outside of the OS by itself, so you can get updates anytime they are released much sooner than just waiting for the next major version of Android. The IDE integration is not as performant or as nice as with SwiftUI and Xcode, personal taste at least, but I think that is going to improve fast. And the recent version of the IDE in IntelliJ is actually bringing a lot of improvement in that sense. And in terms of coding, the two are actually very, very similar. Aside from the approach, obviously it's the same, but even the code that you write are very much aligned. And that gives you a lot of benefit, in my opinion. The first one is that you can have an iOS developer picking into the Android developer and just share the way they're creating views. There's no big issue, a big, hurdle into reading the code on one side and the other one. So yes, you still need to write the code twice, obviously, one for each platform, but you still are able to understand exactly what is happening on one side and replicate that on the other one. And with SwiftUI and Jetpack Compose be entering the game in the system industry, you get, let's say, a convergence about what will be the way of building UI in 2013 or in 2021, a few years back, which is declarative UI is the way of building UI components from pretty much nowadays. These are a set of challenges that I find myself and my team when working with declarative UI. We started implementing the declarative UI component into our own application 2 years ago, more or less. And for some specific screen, we decided just not doing it because it was too complex, it was not plain nice. But the more time we invest on it, the more we see that some challenges still apply today when it was not simply a bug to be fixed back in the day. So I'm going to bring some of these challenges from my point of view. And I'm also be focusing more on Jetpack Compose side, but most of these things are actually applied in the same way as SwiftUI. So you get exactly the same problem in a sense. State handling. You have two things in building UI in declarative. You have the UI, hopefully, and the state. So you need to take care of both and do it properly. State handling is not an easy thing to handle because it's so central in the way you are gonna build it for the UI itself. There are three elements in this case. One is the state hosting, which is a nice way of saying who is actually, or responding to the question, who is actually holding the state for the UI element. Technically speaking, as suggested also by Google, is that you should create your view of the smallest one to be as stateless as possible. So the state should come as a parameter in the case of Jetpack Compose, and then the UI is rendered because of that state. And then you go up and up a level, so you create more function that wrap your function, adding more other subviews, etc., up until you reach the point in which you have the whole view on screen, and in that specific screen, you should have the state stored in that level. Or of your model, if you will. It's up to you. But the point is that the state is controlled and hosted by a single view, and everything else goes down to be simply as a parameter of that state. That simplify a lot those state changes down the chain. Architecture. Again, this is more up to you how you want to build that way. Google, again, suggested to use MVVM as approach. On many documentation, they provide you as using the view model as an element to store the state and apply state changes. I agree with Google. I think that's a very good approach, and it works fine on Android development, also because it's well integrated with the HILT, so a dependency injection, and gives you a lot of benefit into using this sort of tooling. But again, it's simply a view model, so in the name implies it should be something tied to the view. It's not something that should contain the database and other things. It's not their purpose to have all of that part all that code into the view model. The view model should use that, obviously, but it's not. This is not its purpose. Its purpose is to simply react to UI events, apply changes to the UI state, and that's it. Plus, again, do some side effects, if that's the case. But again, this also implies that the application state is not the UI state, or not specifically. You might create some UI state specifically for this view, which is derived from the app state, sure, but it's a completely different object. And that gives you the freedom to actually change some implementation on the backend while keeping the UI exactly the same, or simply expose to the UI the bare minimum set of information and property that are needed for the UI without relying on the full data object that you are creating on the database, for example. Equals. I don't know how many of you try to use a simple data object with Compose. You know that if you have implemented the equals in a way that it simplifies some management in terms of updating this element in an array, for example, that uses internally the equals method on an object to understand if two instances are of the same object or not, which is good in that sense on imperative UI because you are forcing the refresh on your side. But for Jetpack Compose, if two objects are the same, or the state is the same, no UI need to update. So it doesn't matter if you actually have some more property or specific property inside an object which has a change. Those are not reflected because the equals say, yeah, those are the same object. Nothing to do here. But it's actually, you have to do something. So be aware that we fight with this a lot in the recent weeks because that was the implementation that we had on the data layer, which again was fine. In imperative UI, just the way to go, and it was not a big deal. And it gives a lot of freedom in other parts of the code. But for Jetpack Compose, that was a pain. And the only way we found out to keeping the UI correctly in sync without changing all the backend, I mean, still in mobile development, so API, etc., database, was to actually duplicate the data model and having built that as a data class so that you get the implementation of the equals that consider all the properties of that object and work around that by just simply migrating from one type of object to the other one. It's painful anyway. It's not a great solution, but at least it works and it gives the UI the benefit that it deserves, at least on the declarative part. Testing. We never talk about testing with UI, right? Kind of a thing to not say anyway. I think that every code we write, it should be tested in some way, even manually, for example, bare minimum, we say. But that will be something to evaluate. There are view tests you can write, obviously, as we also said a couple of talks before. You have Android Compose, view test, view runner. So you can even test the view by itself. But I give you some suggestion that we build previews for Jailbreak Compose. Previews are tests in a way, because you are fully controlling the state that you're passing to the view, and it's rendered there inside the IDE. So to me, that is a super easy example of testing complied to the view. It doesn't run across CI, it's not applied in that way, but at least give you the freedom to try all the different state options on the view and see how that's react, even in parallels, because you can have multiple previews inside the same screen. That is the way we consider testing view on our company. You can do screenshot testing, sure, but that's a very complicated and also requires a lot of work, because if you change it just a single pixel, a single color, a single padding, everything will be set as, oh, this test doesn't pass anymore because the screenshot has changed, which is the whole purpose of the screenshot testing. But it doesn't bring you actually any more confident than just having to check yourself if all the preview runs correctly on the screen one time. So if you touch the view, you have the preview there for you. That's more than enough to actually do view testing. And if you use view model as a component for handling the state, the view model is a simple object that exposes the state. You can test whatever you want. It's handling the input or the intent, as we said before, and then you expose the state, which is perfectly something you can assert on to be equal to some specific values. Everything is super easy testable in a unit test way. Demo screen as a test. I consider this as a test for the designer part. We started from a design for most of the company, building this, try to implement the screen, following the design as much as possible. But at the end of the day, things changes, even the application and the UI and the feature of the application start diverging toward adding in a few things here and there, changing paddings and other optimization that goes a bit far away from the actual initial design, which is fine. But then the designer needs to have a way to understand which is the actual code inside the application, because if it relies on the design on Figma, for example, which is fine, that doesn't represent what the application is actually doing. And looking for a specific taste, maybe in your production application, on your beta application, whatever, it's actually hard to actually find the right test for the actual product or whatever to actually understand if the design still applied or not. So if you invest onto building a preview on your side just for your developer, you can use exactly the same model with exactly the same state also to build some demo scripts. We created a developer section inside our mobile application. This is just for, let's say, the staging variant of the application. It's not in production, obviously. But the designer can access to that and see all the screen we built just by Compose and how all the state are actually rendered on his own device. So you can have a direct feedback about everything that he needs to consider whenever you need to touch something. And it's an invaluable feedback for them as well. Like maybe I can just update some padding, sure. Then you know which is the effect that padding applied to all the viewing of the screens. So this is a case in which, to me, it's comparable to the testing anyway of UI. The most painful part of UI test or related to declarative UI is that whenever you have to also integrate with imperative UI, you have already screen written in a previous, let's say, on imperative architecture, which totally fine. It's probably in most of the cases you are in this exact use case. Making these two work together, it doesn't play always as nice as they should, even though there was some nice, let's say, abstraction and interoperability between the two. Sometimes you need to just face it that those are two different words, and now you need to or rewrite everything, probably never gonna happen, or you start building different things to making sure that those can actually coexist decently. That's a new way. Teaming is one part which can be complex. It depends on how you actually created the team for your own Android application. But if you're using Material, for example, Material works transparently on both sides, but you have to use Material exactly the way Material was meant to be used and not just stretch it to the way you want to be used. If you use it as a bare, let's say, Material design, applying color, etc., you get perfectly working on both type of views on the UI. If you don't, up to you to decide how to handle this case. In our case, we actually decided to simply create a separate teaming for the composed UI elements and simply have the two coexist up until we migrate all of that to Compose. But this is a choice that we need to do at product-wise. So this is up to you and to the company to decide if that's a journey that you want to be doing or not, because it takes time, of course. Navigation, which is not strictly UI, but still an important part of the UI part, in my opinion. This is kind of a mess. If you use, again, compose only or imperative only, that's kind of fine. And if you have also a simple navigation, just maybe a one on main screen plus some other subviews, it's fine. It's not really a big deal. But if you use navigation which is more complex, sorry, you maybe have a tab bar, for example, that all the stack needs to be independent of one another inside. You have several activities that opens up. You have also support deep links. That opens up a lot of question and problem in general. And if you have everything working on one side and you want to consider that, yeah, just compose will just be fun to have this some UI element more, yes and no. Be evaluated that can be costly in the sense. And the final part to me, specifically whenever you have a mix or an hybrid UI application in that sense, is to try and enforce you to be able to release things as fast as possible. And whenever you have some small view converted to compose and you're happy with that, try to release it in production. This is the only way for you to truly understand if what you built so far makes sense and if everything you have, say, only reason and just think that it should work fine is actually working fine. And the sooner that you deploy those changes in production, the better it is. You get feedback early, even though it's a bug or not, but you get that early so you can fix it for your next view, your next work, or next migration to be done. So this is, for me, in general, one practice that I try to do a lot in the company. We try to do a deploy each week. We can do it even each day, but we have to do other things, and not just mobile application changes. But it's something that is doable. And you can upload an application and having that in the store in less than 24 hours nowadays. So it's not something blocker for weeks or days like it was in 2010, for example. So I'm wrapping up just to say something which is obvious probably by this talk is that declarative UI is the future of the new UI also in native development. The concept that it brings are something new to this industry, but it's clearly used also in other one. So we can leverage the knowledge of other platforms in other environments into mobile application development. Imperative is still a good option. It's surely a bit more performant if you actually need to squeeze the very final part of the performance of your device. But if it's not the case, which is probably it is something, it's not for the case, imperative is just the way we did UI implementation up until 2019 or 2021, depends on the version you are supporting. And that's pretty much it. So thank you very much. Do you have any question? Like, who are these guys? Do you know? You are too young for knowing, right? Microsoft, just a few. Please, yes, sure. Back in the days when we described this, you had two options. One was the first that you showed, the second was by some sort of example. If the example shows you it is to me still imperative because what you build in the layout is just the basic framework of the layout of the page or the view. It doesn't do anything else. So you're just putting the element on screen in that specific position. But then that layout, yeah, you can use binding library a bit more fancy that days. But the point is that you still have the code to actually update each element on the screen. One of the first slides that I was presenting, the one for the example here, the first one comes from a layout XML. Yeah, this is fine because you set the structure of the view element, all the place, you have a label here, a button over there, it's fine. You're setting the styles even in the layout XML, but then the title can change the button. The button can be displayed or not based on another state, which is outside the knowledge of the view. So I consider this still, even if it was much nicer, working XML gives you a lot of freedom there, but it will still then allow the code to write on the other side on Java, this is Java code, by the way, or on Kotlin to actually apply the final changes. So you always have this imperative approach, even though you started from a much, let's say, visually appealing way of building a UI in the XML. Absolutely. Yeah, in imperative UI, there's no engine. I mean, it's just rendering on the screen, so it's up to you to actually make all the changes on the UI. In declarative, you have this sort of component that does all the diffing, which is understanding what part of the state has changed, and then also understanding which part of the state needs to be reflected in which view. So try to understand to minimize the work that needs to be done by the engine itself. And as again, I think it's a very good piece of tech to actually be working on. I think that diffing algorithm is something that should be studied in a way more carefully. But it is what it is. The powerful of using the creative UI is because you have that engine behind the scene, and it gives you a lot of freedom to write less code because the work is done by him, not by you. It's fine, but you need to understand how that works because in some cases that you don't see the UI reflected the way you are thinking it should be reflected, there might be something that you actually lost on the state or on some in another place. So the engine is still core to this sort of process. Please.
How can I convince my management to change from imperative to declarative?
The way we are doing it is to say we need to build something new in the application as a product. So business want to have something new in the application. And we are putting some sort of, let's say, flag to say we are not going to build imperative UI anymore. So the new screen will be injected by compose. They cannot say no because actually they need the new screen to be on play. So that's fine. And this is the way for us to start migrating the application piece by piece to the new approach. It's slow at the beginning, obviously, because we need to actually start becoming much more confident and experienced with the tooling. But again, after a few months, you start getting all the problem. You're solving the way you're reading the code. We do code review, NPRs always in the company. So it's easy to maybe you forgot something and your colleague to say, oh, you actually missed that part that was necessary for. So you are always growing internally as a team. And so moving forward, we just compose on the Android and also on SwiftUI in this case. That will be the same.
Thanks.
Other questions? Thank you very much.